things that you as a web developer might be used to that, that Chrome apps, for security reasons, don't allow. So to begin with, you can't do things like use eval. Eval, source of a lot of bugs and security issues to begin with, but CSP says you can't use it. You can't use things like new function, right? Basically dynamic code execution, something we don't allow. Your JavaScript code has to be kept in separate JS files. And so, for example, you can't have your HTML file with a script tag in the head and then random JavaScript. And because we don't know how it got there, right? So if somehow somebody's able to hack your app and shove JavaScript code in there, we can't have JavaScript code that we don't know where it came from. So we force you to list it either in the manifest or include it as an external JS file to handle security. You can't do things like have inline event handlers. It's a bad practice anyway, but you can't do things like body onload equals run some function. You have to use the add event listener approach, that kind of stuff. Unobtrusive JavaScript approach. If you use iframes, which you can do, they get sandboxed into their own origin. And we do that obviously so that the two sources of content can't mess with each other. Now you can communicate with them. You can use post message to post messages into the iframe, and the iframe can post messages back out again, as long as you do it first. Your app has to be the first poker, right? And then the iframe can poke back. The iframe can't initiate stuff like that. So you can communicate and pass data back and forth. And you need to declare where your content comes from. So for example, if you want to use XHR to get data from a remote origin, you have to, in your app's manifest, you have to ask for permission to go and get data from whatever origin you want to get data from. You can't just simply open a connection to some random site and just start getting data. And the question usually comes up, but wait, I really want to do that stuff. I really want to be eval. I really want to, do things I'm not allowed to do. There are ways to circumvent some of these things, and we realize that there are certain circumstances where you want to do this, so we try to make it as safe as we can. So first, the most common case, or one of the most common cases, is you want to embed web content inside your app. And so you can do that with iframes, but we also give you a web view control, which is essentially Chrome running inside of a Chrome app. And it gets a little bit Inception-like at that point, but it's really cool. You can load content. There's a whole bunch of rich events and APIs you can use on the web view control. So if you want to embed content in your web app that's rich, comes from a foreign source, the web view is a good way to do that. For accessing remote resources, one of the things that Chrome apps requires is that other than audio and video, resources like images, for example, have to be local to the machine. So back in that Economist example where they were showing all those photos and stuff, all of those photos are downloaded locally to the computer and then displayed inside the app. So basically you can do things like fetch those resources with XHR, save them locally in the file system, and then use object URLs to refer to them. And in fact, that's a pretty common pattern. So on our GitHub, we have a library that does that for you. You can just include the code and just go ahead and use it. We actually wrote it for the Economist guys, and we open sourced it. So. A common problem arises when you want to use things like templating libraries. So some templating libraries use things like eval and whatever else to build their templates up, right? So there's a couple things you can do here. One, you can use a library that pre-compiles templates, Handlebars does this, for example. Or you can use what's called a sandbox page. Your app can designate a web page that doesn't have to be visible as what's called sandboxed. And just like iframes, it gets sandboxed into its own origin. And then that sandbox page can do all the things I listed that you can't do on the previous slide, right? So now you can do things like eval and inline event handlers and scripts and head tag and all that stuff. So you can put your templating library in a sandbox page, have it go do its work, and then that page can send a message to your app saying, hey, I'm done, here's the finished HTML, and you're off and running. All right, a little bit about mobile. So Christian talked a little bit about Cordova. We also do work with the Cordova guys. We have a team up in Waterloo that is busily contributing Chrome APIs to the Cordova project. I think we're actually one of the bigger contributors to Cordova these days. So what we're basically doing is we're taking some of the core Chrome apps APIs, like identity, like storage, like notifications, and we're building those into the Cordova open source project, which is where PhoneGap comes from. So the difference here is that on the desktop, the runtime is Chrome, right? It's obviously it's not the Chrome UI, it's the Chrome runtime, but it's the drawing service. But on host mobile OSs, it's whatever the web view that OS supports is, right? So on iOS, that's the UI web view control. On Android, it's the well on KitKat these days it's Chrome, but prior to that it was the Android web view. So that's the main difference there. So what you're essentially doing when you're using Cordova is you're building a native app, and the native app just acts as a host container that wraps the web view, and then your web app gets loaded into that. So the workflow is pretty straightforward. You install the mobile tool set. You can start from scratch. You can import an existing Chrome app. It's really up to you how you want to work. But the idea is that you simply iterate over your HTML, your JavaScript code. You debug using the Chrome dev tools, and then you distribute that via whatever the native store is. So Play, Apple App Store, and future platforms as warrants. We haven't decided yet. So we're busy porting over a pretty basic set of core APIs at first. So these are the ones that we're going to be porting over. And we've got pretty good coverage so far. Actually, this may be a little bit out of date. I think notifications may be done by now. Payments, we'll see. We're not entirely sure that Apple's going to be too happy with us about that. But the idea is that you should be able to build your Chrome apps using this core set of APIs and have it work across the 6 OSs, the 4 desktops, and these 2 mobile ones. We're pretty far along in that. I think we just really, about 2 weeks ago, we announced the developer preview of mobile Chrome apps. All of this is on our GitHub. And in fact, let me just jump over there right now. I think that was my last slide anyway, yes it was. That's my contact info. So let me just jump over to our GitHub. Yeah. So if you're interested in learning about this stuff, this is our GitHub page. All of the APIs have an associated sample. You're welcome to fork this and submit contributions if you want to. But this is the main repo for all of the Chrome app stuff. And the developer site to go and learn about this stuff is here on developer.chrome.com/apps. This is where we have all of our docs about our various APIs. So let me go ahead and just bring up the API Explorer. So you can see there's a step-by-step. We have a full working code lab on here, as well as all of our samples. So if you want to see how various APIs work, there's samples that show that. But we also took the to-do MVC project and made a Chrome app out of it. So if you want to see how a real full functioning working app works, there's a code lab that shows that stuff. And let me just bring up the API. So here's our API reference. You can see that the API set is actually pretty rich. So these are all the APIs that we've implemented so far. And because of the way Chrome works, we have our stable, beta, dev, and canary channels. The APIs actually work their way through those channels. So in the canary, you'll have up-and-coming APIs. We're getting feedback on those, and then they make their way down through the stable channel. And I think Canary's on 34 right now. And then we list out the various APIs according to where they are. So this is all the stable stuff. Then we have our beta stuff, the dev stuff, and then there's a collection of experimental APIs as well. So let me just show you a quick demo of how this works. We actually built, so this is a Chrome app, by the way. This is our developer tool Chrome app. If you've ever used the Chrome / extensions tab in Chrome to load extensions or whatever, that's what this is. It's just been refactored as a packaged app. So you can see that I've got my unpacked apps up here. These are all the installed ones down here. So I can do things like launch. This is our embedded browser sample. So this is an app that shows using the web view, the embedded web view, to make, well, essentially what is a browser. And so I can do things like, it goes to Google, I can go to various places. Let's see, let's go to developerweek.com. And I think actually it's not smart enough to do that. So let me put that in there. Oops. And, all right. So yeah, so you can see that works. We also have, so the WebView control has a pretty rich API. I can simulate crashes because, Chrome never crashes, so I have to have a simulator for it. So I click on it, you can see we simulate a crash, right? Anyway, all of this stuff is available online. So if you want to see how any of this works, please just feel free to visit our GitHub. For the GitHub for the mobile stuff, it's just github.com/mobile Chrome apps. All there is to it. So I think that's pretty much all I had. If you want to see just a quick version of the source code, you guys can read that. Yeah. So our manifest file format, very, very similar to the Firefox OS manifest format. In fact, hopefully one day these things just converge. There's no reason why they need to be separate or different or anything like that. Hopefully one day we just have a nice common API for building these HTML5 based apps. But you can look at it. It's pretty similar, right? Like all you're basically doing is describing what the app can do. In this case, there's permissions for using the web view, but there's a pretty rich permission set. So it's all JSON, HTML, and JavaScript based. So if there's any questions, yeah.
How do you work around the jQuery CSP problem?
How do you work on the jQuery CSP problem? I think jQuery itself actually does work in Chrome apps. We have a current bug in Canary that is, I think, being caused by CSP, but normally it works just fine. But the general case is if you have a library that violates CSP, what I would normally do is put that in a sandbox page. I don't know, maybe Ember, for example, or Mustache, or somebody who has to use, dynamic code execution for some reason, right? Put that in a sandbox page and then just message between the two. So, yeah. Questions here?
So are all the stable APIs on mobile consistently implemented, or do you have some on Android and some on iOS?
Yeah, so we're trying to be as cross-stable as we can. The only one I think, so we chose a set of APIs that we thought had a good coverage of baseline stuff you need to do in a Chrome app, right? The payments one we wanted to do because we wanted to make it easy for developers to do payments. The question, of course, that becomes more of a policy decision than an API one. But the idea is that when the API is implemented on each platform, it's as consistent as it can possibly be. There are certain things, for example, on iOS that are kind of weird, like alarms, for example. They just work differently than they do on Android. So we try to make it as close as we possibly can. The idea is that in the docs, the idea is that when the docs are done for mobile, it'll call out any idiosyncrasies that there happen to be. But the general idea is that it should work as close as it possibly can across the various platforms. That's our goal. Yeah. And so one of the things I want to point out, that's a good question. One of the things I want to point out is that when some of these APIs today obviously are not standard, right? We had to make them up. The same way that Firefox had to make some APIs up. But the idea is that whenever we do that, we first ask ourselves, does HTML5 do this? If it doesn't, then we'll make an API. But every API that we implement, we do it with an eye towards eventual standardization. And so that hopefully it'll be standardized at some point. And everything that we do is open source, by the way. All the stuff I showed you, it's all in the Chromium source tree. Anybody can go to the Chromium source tree to see what we're doing, and it's not secret, so yeah. Other questions? Yeah.
Why the app launcher? Why not use the operating system launcher itself?
You can actually. So the question was, why not just use the operating system launcher? So for example, we did build the ChromeOS-ish launcher in here, but if I actually go to the applications folder, you'll see them in there, right? Let's see, where are they? Anyway, so if I go to Searchlight and I search for let's see, 500 pixels. See, it shows up.
Okay.
Right. So the idea is that in addition, we wanted to give users two things. One was a consistent launch experience, but also whatever the launch experience on the platform was as well. So as a developer, on Windows, for example, I can put my apps in the little start menu, right? On Linux, they can go in the little launch, whatever Ubuntu uses, right? On Mac, it's Spotlight, it's the dock. So this guy right down here, this guy right here is a Chrome app, and you can see he's docked into the dock, right? So I can pin things in the dock. So yeah, it's whatever the OS supports in addition to our launcher. Yeah. You don't have to use this, by the way. If you don't want to see this, you can get rid of it. You just turn it off. Yeah.
I was going to ask. So now that these Chrome apps can be PhoneGapped or Cordova into Android, what's the drawback? Why do I still need to use Android, or vice versa, or whatever?
Okay, so the question is what if these apps are going to be hosted as Cordova on native platforms, then why still use Android? That's basically what
right. What's the rationale today?
Yeah. So I mean,
there was one.
I think if you look at it's kind of funny. So I mean, Brian is a friend of mine as well. If you look at what happened with PhoneGap when they first came out, their mission statement, their website actually says this: their mission is to not exist, right? They actually want to put themselves out of business because their idea is they want to demonstrate the way forward to build HTML5 apps out of native technologies. So in some ways, Cordova is an interim step. Another way to look at it, though, is not necessarily an either-or choice, right? Like let me put this might be controversial, but I'll say it anyway. Even if we had the world's most perfect web-based API set and operating system, there will still be people who want to use native code for a variety of reasons, right? Yeah. And that's not a bad thing. So part of it is you can think of it as just expanding the developer pool, right? There are certain things that as a native developer I get to do that web developers unfortunately don't get to do today. So Cordova is an interim step towards getting web developers to that same level as those guys. So yeah, I mean, if you're an app developer who you care about reach and your app is suitable for Cordova, I don't think you're going to build Halo on Cordova anytime soon, right? But if you're building an application like the Eater guys, for example, they built their app out of PhoneGap, and it works great, right? Because what they care about is getting reach, right? Their app is not terribly complex. It doesn't require Twitch game style performance. So I think that there's a space for those guys where they need to be able to iterate quickly, get their app out there, and so on. Whereas native guys can take advantage of what they know how to do, and there's certain things that are just better suited for native code. So the way I look at it is not necessarily why would you choose one over the other. It's more like giving the ability to develop native-like mobile applications to a wider group of people is a good thing. So.
I guess also if you target older Android, you have no other way than going native.
Yeah, that's true. There is also the question of older operating systems that don't have rich browsers that can't do some of these things, and that's true as well. As time goes forward, that will become less and less true. But yeah, I mean, Cordova, I think we're going to look back on Cordova in some number of years and say it was a good interim step, but it's not the real solution. Right? So, yeah.
So in terms of platforms, so you're looking at Windows, but not Windows Mobile. Is there any reasoning behind that?
You mean Windows Phone? We're not looking. Yeah, not currently. No. It's we've got our hands full with Android and iOS right now. It's not that we don't like Windows Phone. I mean, I was on Windows Phone before I went to Google. But yeah, it's right now. We wanted to target right when you're building something like Chrome apps and trying to get it stable and get it out to people. It's good to just target a minimum viable platform, and right now that means iOS and Android. So.
And one more. So Opera now is forking Blink. So
yeah.
Is there any plans of them also trying to support Chrome apps?
So now that Opera is forking Blink, are there plans for them to support Chrome apps? I don't know of any.
They have native HTML5 apps in the Opera.
Yeah, they do have something similar. I have to confess, I'm not terribly familiar with it, but they do. I do know that I think Opera can actually run Chrome extensions now. So I don't think there's any technical reason why they couldn't. But I don't know of any plans.